So this is my latest project. I've managed to get some sort of automatic throttle control sorted out for my generator, and it's just using an Arduino, and I will show you the code at the end of the video. This is by no means finished. There's still problems. I find that the Arduino keeps cutting out and needs to be reset frequently, and that's even with me powering it off an external battery. Powering off this LiPo battery here, but even still it's cutting out. It's getting a perfect supply of clean power, which should be very low in noise, but I'll show you it working anyway. Oh, and I've left this grid tie inverter on. That's not so good. And I've changed my voltage set points. Anyway, so I'll turn it on just now and show you what happens. Basically what happens is, when the battery voltage is low, like below 26 or whatever, I don't know exact voltage, it's different in practice, the throttle is all the way up full. But when it gets up to the fully charged voltage, the throttle starts to back off. I'll switch the grid tie inverter off just now. Well, let's start this up and see if it behaves itself. Right. Like I'd switched the fuel off there. Right, that's the fuel on now. So as you can see, there are clearly some issues at the moment. It seems to surge around quite a lot. So I think there's going to need to be some alterations in code to help prevent that. And it's not because of ADC noise, I think it's just because of the way I've programmed it. So what I'll do is I'll get the battery voltage up a bit more, because it seems to only surge around when the battery's at a relatively lower state of charge. Okay, so I had to manually hold onto the throttle to calm it down a bit, so I want to switch on the grid tie inverter and put some load on it, and I'll show you the throttle increasing automatically. So the grid tie inverter is drawing more power now. switch off the grid diverter. So as you can see, there is a bit of an issue there. We are sort of getting some sort of control there, so when the grid tie inverter is drawing more and more power, we're getting an increase in throttle, so that's what we're looking for. But the surging has nothing to do with the engine governor. That is obviously an issue in the programming, so I'll need to try and sort that out somehow. But when I have just the solar charge controller produce the power on its own, it works very smoothly. As the voltage increases, it backs off really smoothly, and then as the voltage decreases, without the generator running, if I'm just running stuff, it does work really smoothly. But it's just when the generator's running. I think it's just because when the throttleness goes right the way up, the voltage changes so rapidly, and then it backs right off. But because the batteries are under load and they're at such a low state of charge, the voltage goes way down again, and then it tries to compensate for that, and then it just it's this messy surging. But that's all it is. It's just an Arduino connected to a servo. Where it's just going into A0 through a potentiometer. I couldn't find any voltage sensors online, and the voltage sensors online are just voltage dividers, so I made one up, which is just a 1 kilo ohm resistor, 10 kilo ohm resistor, and a 5 kilo ohm potentiometer, and the potentiometer is just there for calibration. And basically this is designed so that if 32 volts comes in, 5 volts will come out. But in practice, we want the voltages to be lower than that. I know I'm running at higher voltages just now, but that's because the batteries are cold. But in summer, the voltages that I'm running this are totally unsuitable, so I'll need to change the code, or just make a mechanical adjustment. That'll probably be easier. But the idea is to have like some sort of hysteresis value of a range of like, from the battery's point of view, like from like 26 to 29 volts, say that could be the throttle range that we're trying to operate within, where 29 volts is lowest throttle and 26 volts is full throttle. Now I'll go inside and show you the code. Yes, I've not been up to much because it's the UK winter just now, and the weather is just absolutely crap, and it just makes you not want to do anything. The sun is like, it barely comes over the top of that shed up there. That's how rubbish the winters here are. I'd like winter if we got a bit of snow, but we just don't seem to get very much anymore. Although we might get some later on. So all I'm using is just an Arduino Uno and just the usual Arduino software, and basically all I did was I loaded up the servo example. It's in here, and you could just load it up, and this is it here. And basically I've left it completely unchanged. All I've done to the servo example is just in here, and I've just changed just these two values, and basically what these represent are the ADC input. So 0 would be 0 volts, and 1023 would represent 5 volts. And this is on the other end of my potentiometer. Obviously 884 and 1000 here is representing a range of voltages, so I'm not sure what voltages these are representing exactly, but it's between, this is representing, let's just say 26 volts, and this would be representing just 29, and that's basically all I've changed. So it's just mapping these two values to the value that the servo accepts, 0 to 180 degrees, and then obviously using the servo library in here is just basically writing that angle out. It's putting that out to the servo so it turns basically according to this value, and that's all I've done. But it looks like there's going to need to be more done to this to eliminate this severe surging problem which you saw previously. So I don't really know what modifications I could make to this. If anyone does know, if you could tell me in the comments, that would be brilliant. But this is where I'm up to.